Okay, hi everyone. Thank you for taking the time to be here today. I'm Dr. Hannah Ali, so I'm Dean of the Mathematics and the Data Science Department at EAU. I'm here today to discuss with you Project Heatwave, which you can see here. So Project Heatwave is talking about extreme heat waves, so extreme events that are happening, and they're becoming more frequent and more intense. They pose serious risks to public health, as well as economies, as well as ecosystems. Countries like the UAE is going to be the first affected by these heat waves, as we are in a region that will be hit first, as well as South Asia and the US, like Miami, for example. The reason for Project Heatwave, which is going to combine things like AI, machine learning, meteorology, environmental sciences, is to guide decision makers on how we can best mitigate the devastating impacts of heat waves by using reliable tools that forecast heat waves. Thank you so much for being here today. I'm going to bring on David Toman, who's going to be our moderator, and then we're going to have a short video. Thank you so much.
Yeah, fine. Good afternoon and welcome to the Emirates Towers. Just to thank you all for coming. I think it's fantastic to have such a great turnout and such a diverse audience. So why are we here? Partly, a fantastic bit of research. And this is research led by Emirates Aviation University, Dr. Hannah Ali, and colleagues from NYU and others. And it's kind of a celebration of what we can do when we start to collaborate together. So what I'm really, really pleased is that so many academics, so many colleagues are here as a start of our journey in terms of research in Dubai. And I'm very kind of happy to help host this event in the Emirates Towers. I'm looking forward to this to be the first of many events that we run. And hope you all enjoy, I hope you learn, and please participate. Please stick your hand up. Please ask questions, and if I've missed something, shout at the back of the room. And particularly thanks to the mums that are here as well for supporting their families. It's wonderful to have this as a family event. This is a country that celebrates families. So wonderful to have so much support from families, academics, academic colleagues, and people from industry and commerce. So once again, thank you. Enjoy the event.
Hello, everyone. Hope you all are doing well at the Heatwave workshop in Dubai. My name is Alex. I'm one of the Heatwave members based in New York City. I'm joined today by two other Heatwave members that I'll let introduce themselves, but I speak for all of us when I say that we are sorry that we're not able to be there with you in person, but we're hoping to share a little bit about our interests in Heatwave's work with you today, as you all are hopefully relaxing between workshop sessions. So with that, I'll jump into introducing myself. My name is Alex Azan. I'm an assistant professor of internal medicine and epidemiology at the NYU Grossman School of Medicine in New York City. I am a clinician by training and still work as an internist in Brooklyn, New York. And then also work as an environmental epidemiologist in our Department of Population Health, where my research broadly focuses on climate and environmental health with a particular interest in heat. And so with those two roles that I have at NYU, I have two primary interests in the work that I'm doing with Project Heatwave. The first relates to my identity as a clinician, where I am seeing the real-time impacts of extreme heat on the health of my patients. And I'm doing work trying to understand best ways for clinicians to be involved in heat adaptation programming, counseling our patients in the exam room with best practices that are being published in the literature, and making sure that we are connecting our efforts with larger public health efforts that are happening in our city in New York, and of course in other practice environments globally. And then in my role as an environmental epidemiologist, I have done work and continue to do work trying to incorporate health outcome evaluations with different climate resiliency initiatives that are happening in the city, particularly as it relates to mitigation of the urban heat island effect. So really trying to ensure that we are centering health and health benefits when we study climate resiliency initiatives. And so with that, I'll pass it on to Rob to introduce himself.
Thanks, Alex. I'm Rob Mead. I'm currently a research fellow at the Harvard T.H. Chan School of Public Health and the Harvard Salata Institute. And by training, I'm what you actually call a thermal physiologist. And what this means is I've spent hours upon hours of time in controlled laboratory environments and climate chambers, evaluating exactly how heat impacts the body. We've done a ton of work looking at how day-long heat exposure affects physiology in vulnerable groups. We've looked at sustainable cooling strategies like fan use or dipping your legs in water. And we've also evaluated upper limits for thermal regulation, so at which temperatures we can't regulate body temperature anymore. My role at Harvard actually has me kind of extending this research into field environments, particularly working with informal workers in India. And this is kind of part of the reason I've been interested in Project Heatwave as well, because of this focus on extending the science from all the way from climate science all the way down to its effects on the physiology, its effects on people.
Great. And I'm Shannon Yee. I'm a professor of mechanical engineering at the Georgia Institute of Technology in Atlanta, Georgia, in the US. A lot of my research and laboratory focuses on inventing new types of thermal energy conversion technologies and thermal transport technologies. So essentially inventing new technologies that allow us to cool down. So for me, whenever I look at Project Heatwave, I'm always concerned about what technologies do we have that we could deploy to either cooling centers or even at a larger scale to cool cities or regions. And I see there's a lot of limits in what our existing technology can do. And so figuring out how we'll adapt and invent new technologies that can address some of the projected long-term heat waves is something I'm very interested in doing with my group. For this conversation, there's a couple of questions that Alex and Rob and I wanted to kind of go through and discuss. And that first question really comes down to what are some of our concerns about the preparedness we have to heat waves on human health, right? So Alex, what do you think?
Thanks, Shannon. Yeah, I have many concerns. And I think I probably have shared concerns with both you and Rob. A few that I want to highlight for our talk today. One as it relates to my identity as a clinician, right? The primary way that the healthcare system is impacted by climate-driven extreme weather, and in particular heat waves, is our lack of capacity to respond to and absorb the influx of patients that we see in our emergency departments and hospitals during extreme heat events. We've seen that with different extreme heat waves in the Pacific Northwest here in the United States and the Southwest as well. And we see evidence of this in other countries that are even more heat vulnerable globally. And so one of my main concerns is, as a healthcare system, we really don't have any existing mechanisms to raise our capacity to be able to absorb the influx of patients that are coming in during extreme heat events. But more importantly, on the primary care side, which is where I work and where we focus on prevention, we have no existing programming and mechanisms in place to make sure that we're active partners in preventing people from even having to show up to the hospital during extreme heat events. And so our lack of preparedness as the healthcare system is basically one concern I have. And I can talk about that for a long time. I think it really first stems with our education and how this isn't a part of our medical education in any way. My second concern is, and I think you'll probably speak to this more, Shannon, as it relates to existing technologies. But as I perform these health outcome evaluations, understanding at the sort of urban microclimate scale, what is the cooling effect we see with different existing technologies that are being more widely implemented in cities like New York? So green space, for example, different high albedo surface interventions. Primarily, we see those on roofs with what we call cool roofs here in New York. It's not a huge degree of cooling that we see, and how that translates to ambient cooling, like the cooling that a human body actually
Technology seems to have failed us. I'm not sure. Unfortunately, that was a fascinating discussion, cut short somewhat. I'm not quite sure if we can reboot the systems. Hannah, let's, why don't we just get the panelists up and let's have the panel discussion. So in terms of filling in the gaps, if I could just ask panel one to come up and we'll accelerate that part of the conversation. I think it's actually better to have these things face-to-face anyway rather than video, so let's cut to the analog face-to-face rather than digital. So we're very fortunate to have three fantastic panelists, and it's a delight particularly to have you on stage and ready to step in at a moment's notice to deal with technology failures in a very sophisticated environment. So Anna, do you want to just lead off and explain who you are and what you're doing here and how your collaboration is with the UAE and Emirates Aviation as an example. So Anna, your show.
Sure, thanks so much, David. My name is Anna Berstein. I am an associate professor of population health at New York University's medical campus, the same as Alex Azan, who we just heard from on the video. And I've been collaborating with Hannah and Zin and others at Emirates Aviation University for a couple of years now. Actually, Zin and I go back about 15 years when we were collaborating on mathematical modeling of the spread of HIV in Zimbabwe and the potential role of prophylactic medications to prevent people from acquiring the virus. And both of our interests have changed over the years, and it's really wonderful that we came back together again, and that brought Hannah into my life and brought this collaboration about. And for me, Project Heatwave was part of this arc where at NYU, I am fortunate to have a laboratory that asks the question, what is the best way to use limited resources to provide the most health possible to populations? So for example, in combating the HIV pandemic, how much should you invest in treatment versus prevention versus testing, et cetera? We have actually from here, I'm flying on to Southern Africa to a small country called Eswatini, where we're asking the question, what is the best package of health services to offer the population in a place with very limited budget, very few doctors in the population, that provides the most health possible? Should you treat hypercholesterolemia? Should you treat cancers? Should you treat hypertension, infections? If you can't do everything, what should you do? And over this time doing this research, I came to learn more about the effects of climate on health. Just to give you a perspective, in the world there are 40 million people living with HIV, and my lab at NYU is not the only lab asking these kinds of questions. There are many, many labs studying the epidemiology of HIV. When it comes to extreme heat, in my lifetime, on the order of 1 billion people, with a B, billion, live in places today that will become uninhabitable due to heat, where heat will reach levels, the combination really of heat and humidity will reach levels that the human body cannot withstand. And actually, when I say a billion is conservative because a billion is derived from the kind of research that Rob, who we just heard of, does, where people are put in these saunas, these very scientific saunas, and their core temperature is monitored until at some point their body can't compensate anymore and the core temperature starts to increase, they don't put pregnant women in those saunas. They don't put babies or elderly people or people with heart conditions in those saunas. So we know we're being conservative when we say the healthy young adults, the soldiers, the athletes that are part of those experiments couldn't withstand the temperatures that are going to happen here in the UAE, that are going to happen elsewhere in South Asia. I'm being long-winded, so I've got to wrap up. But for me, what brought me to Project Heatwave was wanting to apply these techniques from decision analysis in health to this much bigger problem of the crisis of extreme heat, and discovering that there isn't a single lab that I know of solving this problem for heat. So I'm really so grateful to Hannah and to everyone here who's come together to start to answer this gigantic problem that is unaddressed.
It's wonderful to see enthusiasm at such levels. That's wonderfully encapsulated. Thank you, Anna. Jean-François, you're next.
Hi everyone. I'm Jean-François Lamarck. I am currently the chief scientist at Silver Lining, which is a non-governmental organization in the United States, which is interested in looking at near-term climate change and various options on trying to mitigate and reduce the risk associated with climate change. So some of the things we're looking at are solutions associated with what we call solar radiation modification, so ways to reduce the amount of heat that would reach the surface. I'm a climate scientist by training. I spent most of my career at the National Center for Atmospheric Research in Boulder, Colorado, where I have developed Earth system models, so the tools that are used for climate projections. I was also in charge of the international effort called the Climate Model Intercomparison Project, CMIP. So my research has always been in trying to understand and estimate climate risk, trying to understand what is the role of forcings that we're putting in the atmosphere on extremes. And in this sense, looking at extremes such as heat waves is a very compelling story. This is something that climate models have been trying to look at, trying to understand what is the risk with various degrees of variation associated with different scenarios, different locations, different times, different time evolution. One of the things that is very specific about this is the notion that this is extreme. So by definition, this is something that is very unlikely to occur, but at the same time, it's going to be very detrimental. So this, as a climate scientist, I mean, it's also a very difficult problem to look at because statistically it will happen only very seldom. So one of the things, and this is very interesting to be in this area and building, this is where AI is actually going to play a very critical role, because AI is actually helping us sample the space of the various risks and the various options and the various scenarios and all the uncertainties associated with those. We're able to sample that space a lot more, and then being able to extract the statistics, how extreme is it that we're thinking about. So we're then integrating all the information that Anna was talking about, and Alex and others try to combine just the knowledge of the meteorology that we would provide as climate scientists into something that is relevant to people, and trying to understand what is the risk into the future.
Thank you so much. And last but not least.
Good afternoon. Please accept my greetings and gratitudes. My name is Dr. Syed Mohammad Tayyib Shah, and I'm working as a lead technical at National Emergency Operations Center at National Disaster Management Authority of Pakistan. So my principal responsibility is to develop integrated multi-hazard vulnerability and risk assessment, in which we basically analyze different dynamics of the Earth system. We consider Earth as a complex system which has an interaction of different types of dynamics within the Earth. The there are a number of different dynamics within the Earth system that we basically look into. The hydrosphere or the cryosphere, the atmosphere, and also the biosphere, and in fact the entire ecosystem. And we also see the coupling effect of different dynamics within the Earth system. And one of the principal component that is a part of our duty is to understand the Earth heat budget analysis in order to understand how much is the total net heat coming to us and how it is circulating around the globe. So for that, we are rigorously working on the global oceanic circulation patterns and also the global atmospheric circulation patterns and its coupling effect. And this understanding of the thermodynamics of the heat basically provide us a thorough understanding of providing synoptic outlook of different weather conditions. So we provide seasonal outlook and also different kinds of forecasting of the hydrometeorological hazard. So our approach is first to look into the global emergencies that are prevailing around the globe, so as to understand what of those global emergencies may not become a local worry for Pakistan. And for that, we have a very comprehensive mechanism of collecting the data from a number of different sources, whether it's the space-based data from a different remote sensing techniques and satellite feeds. And then we also have a data coming from the aerial platforms, and then the ground sensor-based data provide us three-tiered data regime. And through this, we basically perform the different analysis of hazard. And once we perform the hazard analysis, then we also see its exposure onto different elements, may it be the population, health, infrastructure. And then we also perform the vulnerability assessment in the dimension of the food insecurity, the water security, and also the socioeconomic vulnerability analysis or the infrastructural vulnerability. And then the last step that we perform is the capacity assessment, either the capacity to anticipate the future risk or the present risk, or capacity to respond to those risks. And finally, we do the multi-hazard vulnerability risk analysis at a very micro level. So this is what we do. With regard to the heat wave, we have a number of different subject matter experts and syndicates that work on different types of hazards in Pakistan. Since Pakistan is primarily arid to a semi-arid country, we have a number of different hazards prevailing because of the geographical configuration of Pakistan. So there are wide variety of hazards coming, which are very prevalent. So what we do, we divide the calendar year into two parts, and in the 6 months, we thoroughly working on the winter hazards. And then in the last 6 months, we performed the analysis of all summer-related contingencies. We have a subject matter syndicate working on the heat wave as well, and there are a number of different subject matter experts from meteorology to the climatology and also to the impact analysis to understand the heat wave, and how we also provide the forecasting of the heat wave, and then provide different global best practices to curb and curtail or either to respond to that heat wave. So that's what.
Thank you so much. I just perhaps like to wind things back a bit to you, Anna, in terms of Saeed was starting to get into there and kind of some of the solutions and some of the kind of the strength of analysis. But if you could explain a little bit more about the global burden and how that operates, and then pass that through in terms of colleagues for their comments and build.
Absolutely. The global burden of extreme heat, I think if you walk out of this room remembering one thing, remember that of all of the ways that climate change will affect human beings, there are two that will affect us the most. And one of them is extreme heat. The other is crop failures. So the effect of heat on us humans and being able to eat enough due to crop failures. So I know climate change keeps people up worrying at night for all kinds of reasons. What about the polar bears? This, that. There's so much to think about. But these are really the top two things. And so it needs to be a focus. We know that already we're destined for an era of climate overshoot, right? So even as we think about what we can do to mitigate the level of climate overshoot, at the same time we have to also think about how will we survive this next era of climate overshoot. And the two focal areas have to be, how do we cope with extreme heat? How do we grow enough food to feed the planet?
I'm going to bounce it slightly differently. But Saeed, how does that see in terms of your environment, that burden in Pakistan, perhaps? How do you see that as an add-on? So what's the burden in Pakistan in terms of heat?
Uh, um, I will say that Pakistan is actually a ground zero with regard to the climate change. And as per the different global climate modelings, and as well as the different, on all different scenarios, we know that the total number of days, the warm days in every year is becoming in higher and higher. Either the day temperature or the night temperature, in all different climatic scenarios, they are becoming more frequent. And what is this causing? This is actually causing the increased frequency and as well as intensity of the heat wave in every coming year. And in Pakistan, the heat wave is becoming very, very severe. And you may imagine that there are some certain cities within the southern part of the Pakistan Sindh where the temperature even goes to 52 to 54 degrees centigrade, which are the maximum recorded temperature in the complete climatological record, even that Pakistan is facing now. And because of that, since we are at the forefront to face different climatic erratic pattern, but the burden of this, changing climatic patterns is causing a number of different domino effect or the cascading effect in Pakistan. Normally, in the month of May and June, because of the conducive environmental and meteorological conditions, the heat wave conditions prevail in our country, and there are spells of 3 to 4 heat waves that Pakistan faces. But this heat wave has a number of repercussions, particularly in the north of Pakistan. You may know that there are around 13,000 glaciers, which is also, even largest number of glaciers outside the polar region. That is why our Hindu Kush, Himalaya, and Karakoram is also called a third pole. Unluckily, because of the rising temperature, these glaciers are melting. And on the one side, we are facing the heat wave, but on the other side, our glaciers melt, and the volume of the glacier lakes are expanding, and the frequency of the glacier lake outburst flooding is becoming very, very higher. And this is also causing the flow in the rivers to become more accelerated. And then in the month of July, as the monsoon approaches in Pakistan, because of the excessive flow due to elevated temperature, both the land surface temperature and the sea surface temperature put us in a stress. Like we are in a sandwich condition of the accelerated flow of the water from our glaciers, and on the other side, the monsoon that comes in the month of July becomes more aggravated. In addition to that, I will also relate it to in the month of May and June, we have around 5% of the total area of Pakistan is a forested area, forest cover. And we have mostly of our forests are the deciduous forests. They shed their leaves during the summer. And because of the elevated temperature, this also causes frequency of the forest fire to become higher and higher every year. Even last day, we had one of the forest fire, even because of the extreme dryness, dry conditions of the winters, because our winters are becoming dry as well. So the frequency of the different disasters are becoming very high because of the global warming. And
Thank you so much. So what you've described is a pretty substantial burden from Anna. You've described it sort of a vignette of what's happening in Pakistan as a here-now problem. So Jean-Francois, do you want to cast your mind to what the risk of this isn't going forward?
So a lot of the climate change discussion is framed in the global mean temperature. I mean, everyone is hearing about the fact that we're reaching 1.5 degrees above pre-industrial, that we're probably on track for 2 degrees or more. The thing that one has to realize is that extreme conditions are changing much faster than the global mean. So there is an acceleration of the extremes that is not indicated by just that global mean number that we're mostly looking at. So what we're seeing in terms of heat waves, for example, is them becoming hotter, lasting longer, and being spread over larger areas. And so what maybe was something that would be confined to a certain region becomes something much broader, and then the population at risk then becomes something that is very much more difficult to handle. So what we're seeing, and we're using those climate models to do that, is that the risk is increasing. There is pretty much nothing that will stop us from going to a much more extreme risk that a 2-degree would indicate. Hopefully, we'll turn around and start reducing. But one thing that is important to remember is that even when we reach net zero, which is a target that we hear about, that only means that the concentration at that level will stay constant. So this is basically the climate with which we will have to live for decades. So we are in a set of conditions that we have to learn what will happen even when we reach net zero. Sorry for the bad news, but the risks are increasing, and we're seeing it in the observations. I mean, as Dr. Sayed was mentioning, we're seeing things that we've never seen before, and so that's becoming the hard part. We can't just use our understanding of the system as we have it. We're reaching uncharted territories, especially when it comes to things like heat waves.
Thank you so much. And perhaps Said, I'm just hinting about that, maybe a ripple effect of where we are now that you might want to articulate for us.
Okay. Because it's not only the first order disaster, there are second and third order, which we, in the language of the risk assessment, we call it a domino effect, a ripple effect, or a cascading effects of the disaster. I will explain what is happening in the future and why it is happening. It is because of the change in the dynamics of all different different types of the climate system, whether it's the cryosphere, which is the snow cover in the different parts of the either polar region or in the different snow cover region, or the hydrosphere, the lithosphere, your land use and land cover pattern as well, and also the biosphere. The cascading effect, even the heat wave is a cascading effect of the change of the total snow volume in the Arctic and the Antarctic region, because we know that the Earth total heat budget, it is basically the amount of heat coming to us and then the amount of heat that goes back to the outer exosphere. Because of the loss in the glaciated or the snow cover, the total net albedo is reducing. And this is causing a number of different teleclimatic effects on different parts of the region of the globe, whether it is Pakistan or UAE. For instance, the total net albedo, since it is reducing, it is also changing the global conveyor belts, the circulation patterns in the ocean. For instance, there is one circulation patterns in the Atlantic Ocean that we called Antarctic meridional overturning circulation pattern. What it does, it takes the heat from the Gulf of Mexico, and then it transports this heat to the North Atlantic ridge, and then it takes this heat and it puts it to the western part of the Europe. That is why Europe has more temperate climate. Because of the change in the thermohaline circulation and the change in the total net snow volume of the Arctic region, the Antarctic meridional overturning circulation is shutting down. As a result, the total heat system of the Earth has disturbed. And this disturbing effect is causing that heat that actually used to go to the northern latitude is now transporting towards the Pacific Ocean, particularly in the Pacific equatorial region. And as a result, the sea surface temperature of the Pacific Ocean is becoming higher and higher. And this rise in the temperature of the Pacific Ocean is then creating another ripple effect. It is making our monsoons more erratic and more unpredictable, and also the type of the western disturbance that comes to the Pakistan from the Mediterranean Sea, Caspian Sea, and Black Sea. We call that the Mediterranean Sea itself is becoming a heat dome, and this heat dome, the Mediterranean Sea, is causing more evaporation index, and as a result, we have seen the flooding in the Spain, Valencia, and that happened because of the heat stress even in the Mediterranean Sea. The aggressive convective precipitation happening in the UAE is also has a direct relation with these oceanic circulations that are changing because of the different coupling effect between the atmosphere and as well as in the lithosphere or the atmosphere. So when I say a cascading effect of the heat wave to us, we call heat wave as an evil twin of the glacier lake outburst flooding of Pakistan. Because we have seen that whenever there are heat wave incidents, we see a more accelerated flow in our north mountainous region, which causes more frequency of flash flood, more frequency of torrential flood, more frequency of pluvial flooding, riverine flooding. It also causes the land surface temperature to become higher, and this land surface temperature creates our crop set stress. It creates stresses on our marine ecosystem as well. The coral reefs, the bleaching of that coral reefs, the ocean acidification, the frequency of the tropical cyclone that hit to us, everything gets intensified because of the elevated land surface temperature. So these are the ripple effects.
That's a lovely way to describe how connected this whole world is and kind of the impact of heat. So that begs perhaps the last question. Anna, what do we do about it?
Well, there's a reason that the Heatwave team is in the UAE today, and it's because this region and the coastal regions of the Arabian Gulf are the hottest, most humid in the world. And in fact, in this region of the world, weather stations have already registered heat and humidity so extreme that people should not be able to survive outside. Now, this region has incredible infrastructure, right? So we're in a lovely air-conditioned space, and because of the technology and infrastructure that's here, we can be safe. But there's so much that we can learn from this region to keep the world safe. And there's so much more to know, because if this is the most extreme, what happens when heat and humidity become even more extreme here? So I really see the UAE as a forerunner for the world, where conditions will become unprecedented, never before seen in an inhabited place, and this region needs to prepare. And then learning from here, the rest of the world, like Pakistan, needs to prepare.
That's such a beautiful way to end the panel discussion. I'd just like to thank three of you for such an enlightening and interesting conversation. It's been fascinating for someone like myself and the audience. If we could just ask you to put your hands together and thank our panelists. Thank you all, much appreciated. Sorry, how rude of me. Can I just, are there some microphones out there? Oh, we have a microphone. Any questions? We got quick 5 minutes for questions, or yes, please, sir.
Okay, my name is Basit Khan. I'm from NYU Abu Dhabi. So I have a quick question, Tayyib, from you. So you described.
It's gone live.
Okay, thank you. So you described the whole Earth system very nicely, how it is changing and climate change is affecting the entire system and increasing the vulnerability. Now, as you described, Pakistan is doing a lot, right? In the previous discussion also, you described everything, how your department and your organization is working. on warning system and everything. So my question is that what climate interventions you're working on, or I'm not asking for the government response. I'm asking as a scientist, to a scientist, that what climate interventions at the moment you guys are working on or you are implementing for the adaptation of the changing climate. Thank you.
Um, I will speak both in terms of the scientific language and also in terms of the policies, developed by the National Climate Change Policy of Pakistan. We have a recently Climate Change Policy 2021, and this is actually a revised policy. Earlier we had a policy, Climate Change Policy 2012. In the policy 2012, since Pakistan has a contribution to the net greenhouse is even lesser than 1%, so we had earlier a stance that we have to work mostly on the adaptation rather than mitigation, because we are not the one who are contributing to the climate change. So we have to do more adaptation. The recently revised policy 2021 has added both climate change mitigation and as well as climate change adaptation. And there are a number of different interventions proposed by the government of Pakistan. For example, Pakistan's pathway to the low carbon emission, and that in carbon emission for every sector, either for the transportation sector or for the agriculture sector. There is a massive, solarization of the agriculture sector, even the use of, the electric vehicles and promotion to use more electric vehicles. There is a complete pathway for Pakistan. And then we have some urban forest, what we call the Milwaukee way of forestation. So we have some designated areas where we have to develop the urban forest as well. And then we have some protected forest and Green Pakistan, green climate interventions. So we are working on increasing the forest cover of Pakistan from 5.2% to 8% and even going towards the 12% by the year 2030. So these are some interventions proposed by the government of Pakistan, and also ecosystem restoration project, the Pakistan Indus Delta Program 2100. We have launched it. And then there are a number of other mangroves forestation protection, the biodiversity protection, and the life underwater, particularly the ocean acidification. It's working on that. That is what provided by the Climate Change Policy 2022. But in terms of what kind of interventions, quick fix interventions, the short-term interventions, mid-range interventions, and the long-term interventions, so a list is long. Number one, for instance, the urban...
Just briefly so we can get another question in maybe.
Okay. For instance, we need to work on developing resilience in our infrastructure, particularly the resilient infrastructure that should support thermal comforts. We should have a vertical forestation, the green forestation on rooftops. We call it, and the climate science call it the green infrastructure and the blue infrastructure. So we have to work on the nature-based solutions. We have to work on the green, to develop more green infrastructure. We have to reduce the gray infrastructure and convert it into the nature-based friendly solutions, whether blue infrastructure or a green infrastructure.
Thank you so much. Just one last question. I'm being prompted here, but one last question. Anyone? We got one last question. I know. Hi there.
Hi, I'm Dr. Deepudev. I just want to know about what are the main sources of this heat wave, how these sources are can be identified to solve this problem.
Maybe give that one to Anna. Does that work? Or Jean-Francois? Jean-Francois, just a quick answer if you don't mind. I know it's a very complex subject and we're giving you about 15 seconds, sorry.
Yeah, so heat waves are basically a set of very stable conditions. So you need the formation of meteorological conditions that are conducive to something that is very stable. It's a high pressure system, so it's also very dry. and no clouds are going to be associated with. So the amount of solar radiation that reaches the surface is just basically without any way to be stopped. So those are conditions that happen all the time, right? We've seen heat waves. It's just now and expecting with the futures that such conditions are more and more likely to occur, and also they will be associated with conditions that are more and more humid. The atmosphere holds more water as it gets hotter. And so we end up with conditions, even though heat waves tend to be really sunny and dry, but the overall atmosphere ends up being much more humid than it is right now going into the future. So the conditions for heat waves and the danger on people's lives becomes increasingly risky because of that combination of heat and humidity.
Thank you so much. Thanks again to our panelists. Again, fascinating. Thank you to you for participating and joining in. So thank you once again. Ma'am, I think you're next. Go on and do the introductions.
Hello. I mean, it's very intimidating to be in a room full of scientists and to be a graduate of literature throughout all my degrees, starting from, bachelor and master's and PhD, all in literature. So excuse me if I say anything stupid or anything not very intellectual, as the majority of the people in the room are really respectful professors. So my name is Sajida Showa, and I'm the head of the United Nations Office for the Coordination of Humanitarian Affairs. Not a typical person to be sitting in a room with intellectual professors as today. But our climate team in New York had a very interesting conversation that started with Hannah and the rest of the team. And we thought that the opportunity is very timely today to probably think a little bit outside of the box, thinking of how can we connect the scientific research, the private sector and academia and research component into what the humanitarians in the UN and the humanitarian system does. Keeping in mind that business as usual for everybody in every sector nowadays is not possible. Just doing things as they used to work few years back in time. So please allow me to move from doing business as usual into giving an overview of what the humanitarians are working on nowadays in relation to humanitarian needs globally, and to link that into the humanitarian needs. In a glance, this is the cover page of something called the Global Humanitarian Overview. And it's more of the main document that the United Nations Office for the Coordination of Humanitarian Affairs put together on behalf of the whole humanitarian system, including UN agencies, INGOs, NGOs, local partners, academia, media, and everybody, as we are mandated as the most senior level of representation of the UN from the humanitarian angle. So today, while we're having this event today, around 305 million persons is in need of humanitarian assistance somewhere around the world. The people that we are trying to target within our response plans are around 189 million of that. And the requirements needed to do that are 47.4 billion. So just for you to get a sense of humanitarian needs globally. Where are these needs? As you can see, they are divided all around the world with all these yellow flags everywhere, which proves that humans are not immune from conflicts or crisis, and consequently, they're not immune from any climate change crisis, the topic of today. So it gives perspectives. I will not go into the different parts of it, but what I wanted to flag is that the main drivers, sorry, can somebody help in removing the chairs here? Just the main drivers of the humanitarian. Sorry. That's exactly what I meant by a graduate of literature. Okay, so the main drivers of those humanitarian needs are conflicts, and it starts with 78% of civilian fatalities in conflicts worldwide are in countries and with a humanitarian plan. The number of civilians killed in the conflict, you can look at the figures. It starts with 0K into 60K with different countries and different dates, and all the data is all as of November 2024. Climate change is the third biggest factor on this side of the screen. It's close, the whole world is close to 1.5 degree of warming, and it shows that climate change is becoming part of this conversation of humanitarian needs. And we're talking equally about people affected by conflicts as affected by climate change. Now, allow me to be a little bit of a storyteller. I have a PhD in storytelling, so I cannot be in a place here without saying something. The UN humanitarian side were not connected completely into the narrative of climate change. As in COP27, the Undersecretary General Emergency Response Coordinator and the UN principals walked into COP27 in Sharm el-Sheikh. And I'm sure that many of you are already engaged or part of the conversations happening in the different COPs. The strong realization is that with figures like 305 million people in need, indicated that there is not a single panel in the COP that talked about how climate is causing humanitarian needs, or how climate is the main cause of internal displacement, or is pushing people to move from one country to the other. So starting from the end of COP27, the ERC has appointed a climate change team lead. A whole team that focuses on climate change led by researchers was created in New York. And I think I was very blessed to be appointed as a country representative here shortly before the rolling out of COP28. And our team completely shifted into a climate change team. We were lucky to be among the first team to be located in UAE and had the privilege to work closely with the COP28 presidency team. And we managed to have wins for the humanitarians and for the people in need that are actually the reason why I exist here and why OCHA and the whole UN system exists, to serve those people in need. So in COP28, and thanks to the generosity of the UAE government, which I want to take advantage of being here today on the stage and flag, throughout their support and our advocacy, we managed to roll out the first day ever in the history of any COP that focused on health relief and recovery. And it was the first day for humanitarians to have a space to talk about humanitarian needs, emergency context, response, coordination of needs, and to be part of the COP28. Again, we were blessed to be receiving funds from the government of UAE on hosting the first ever humanitarian pavilion, which was the first platform in any COP historically happening, where a dedicated space is open for humanitarian and non-humanitarian partners to come and talk about humanitarian issues. 60 partners were hosted throughout 2 weeks. Around 15 or 16 representatives of affected populations by climate crisis were invited to come and to talk to themselves, to decision makers, not only to ask politicians to speak on their behalf. That was big. So humanitarians became very greedy because we're now part of the big festival of the conversation of climate. We cannot leave this now unnoticed, since we already started creating bridges on the scientific research, on the emergency response. We started including in every response plan, humanitarian response plan, a section that shows the connection between climate change and that. We have even invited private sector representatives to be part of the UNDOC search teams, if you're aware of it, or as the first emergency responders in any crisis that happens within 48 hours of what that crisis starts. So it's climate change and heat waves are big priorities as part of our conversation. I think I had a lot of things with me that I wanted to say today. But maybe I'll just try to summarize rather than saying it all. Sorry, I'm triple-hatted today as the OCHA representative here and speaking on behalf of the climate team in New York and bringing on board messages from OCHA Pakistan. So thank you very much for speaking of Pakistan earlier. The key messages from my New York team is that the climate crisis is already an extraordinary driver of humanitarian needs around the world. I will not go into figures and details. The climate crisis accelerates inequality. As it is often the case in times of crisis, women and girls are disproportionately affected. Again, speaking of a humanitarian language, climate-related emergencies impact the poorest and most vulnerable people worst and first. The people that are least responsible for greenhouse gas emission are paying the highest price for their impact, and this is a grave injustice. The climate crisis fuels food insecurity, as you imagine, not only with women and girls, but with food insecurity. A recent study for FAO indicated that for every degree of additional mean global warming, incomes of female-headed households in low and middle income countries are reduced by 34%. So more women, girls, and younger generations suffering. The two last messages from New York team is that the humanitarian system is adopting and responding, helping those most affected by emergencies to building resilience in climate shocks. In COP28, we have launched the SURF Climate Account as an emergency fund for donors that are interested in investing funds for emergencies that happens within the shortest time possible and to be dispersed immediately through local partners and local organizations. That was rolled out in COP28. We're committed to using early warning to get ahead of disasters and help communities avoid their worst impacts. We have another funding mechanism called the Central Emergency Response Fund that spent around $89 million on anticipatory action. And anticipatory action is the smart scientific approach that the humanitarians, non-scientific partners have to showcase how can we connect research with private sector and with other innovative actors that can be part of the conversation. Through the anticipatory approach and through the Central Response Fund, in the past 3 years, we have allocated 65% of the global total, and OCHA is committed to scaling this up to $200 million. The last line that I want to say is that there is no humanitarian solution for the climate change, unfortunately. So the only way for us is to work together with research center, with AI, with private sector, with everybody who thinks that they can be part of this, even with academia, bringing up the narrative. And I'm happy to put myself as OCHA UAE and our teams in New York and the teams in Pakistan that are happy to provide evidence on how the coordination of humanitarian needs can work closely. I just want to highlight a few words from OCHA Pakistan to complement what the colleague from Pakistan already shared. In terms of climate vulnerability in Pakistan, Pakistan is the 5th most vulnerability country. The extreme heat events are massive there. In the role of OCHA Pakistan, they have been part of the forefront of heat wave response, strengthening coordination mechanism and piloting anticipatory approach. They have published 72 real-time heat wave situational reports, leveraged the COBO-based data collection tools, and in terms of contributors, they were the first responders to health providers, into public awareness campaigns, into the heat wave management plan. They contributed into the Sendai leadership framework, and they collaborated with 40 humanitarian organizations to establish 1,800 heat stabilization camps. I think I'll stop here, and the conversation will continue. Thank you for giving me the opportunity to be among this beautiful.
Sajida, that's very kind. Thank you so much. Again, a very enlightening presentation and a particularly helpful slide. So thank you again, superb. We're just going to have a quick video, and then we're going to move on to the final panel.
This strategy is very important for the climate system and for human health. You might expect that because of that importance that we're always monitoring. not the case.
New observations have found new sources of pollution in the stratosphere that are introducing aerosols, space traffic, air traffic, as well as mega fires that are linked to climate change.
There is clearly a change in the baseline that the stratosphere is experiencing. So this still need to fully take into account in climate model. Whatever we would do to it, we need to understand the base state, the role of re-entry vehicles, launches, and all those things.
We've reached record temperatures, more linked disasters are occurring. When looking at the problem of escalating near-term climate change, scientists landed on the most promising approach to cooling the climate system quickly, releasing particles into the atmosphere to change the properties of clouds or reflect sunlight directly.
Stratospheric aerosol injection is one of the approaches that we know with the greatest amount of certainty will quickly create cooling in the climate system. We have a history of natural experiments from stratospheric penetrating volcanic eruptions that demonstrate a strong cooling effect. The real question for us is to understand all the details around how that works. We really have to understand the stratosphere better than we do today.
Climate change is impacting vulnerable people in many diverse ways. We've gotten to a point where we have to face reality, and we need to face the climate crisis with realism. If we do not invest in research into SAI or potential, we are not reducing emissions fast enough.
We in Silver Lining worked with scientists and other experts to identify a map of research. We see this research as dual purpose, not only
So the goal of all research is really to establish the science that we need to really understand from the smallest size, the formation of aerosols, all the way to climate impacts. What are the consequences of uncertainty that is associated with some of those parameters that we don't understand? And I think it's really critical now to understand really at the finest detail, and then bring the information into the climate models to make sure that they are grounded in the real world. So whatever we can measure in terms of stratospheric composition will give us a better understanding of what is the risk. At this point, we are basically limited to just a few airplanes who can fly up there.
The SABRE program at NOAA is really demonstrating the value of being able to carry all of the sophisticated instruments up there that give you that combination of measurements needed to really understand at a process level what's going on. They've discovered totally new things like a large contribution of satellite stratospheric aerosol, totally novel composition and chemistry. One of the big setbacks for stratospheric science recently is the loss of the microwave limb sounder on the NASA Aura satellite, which has given us long, consistent records of stratospheric composition like water vapor and ozone. And maintain some of those records, NOAA's balloon-borne stratospheric aerosol profiles program is doing an incredible job demonstrating a way that we can some of the by Aura and how we might try to monitor for changes in stratospheric aerosols. Stratospheric balloons are really important. They're inexpensive. They can be launched from lots of locations with pretty small logistical footprints. So we're working at Silver Lining to help with both of those elements. That's the goal of our HOPE ballooning effort, to help maximize the usability and reusability of balloon-based observation systems, to bring stratospheric measurement capabilities to researchers around the world who haven't had access to them, which could be really valuable in a world where people might intentionally release aerosols into the stratosphere in the future.
Everything is dependent on what is the distribution of aerosols. So aerosols interact with radiation, so it's critical for them to be of the right size. So we have to understand from first principles at the generation of particles, what is the chemistry that's happening, in what conditions, and how quickly, in what number, in what size, how quickly do they mix with the environment, because all that is going to define ultimately the response of the climate system.
We're trying to predict and model the behavior of this aerosol plume we're looking at. And in order to do that, we have to actually make detailed measurements of the data to anchor those models so you could have an ideal prediction of the behavior. With this experimental test configuration, we could actually simulate different boundary conditions and
to be able to measure the aerosols that we're generating with a really large degree of fidelity and accuracy. Laboratory field experiments, modeling studies, to formal assessments that draw those things together to create kind of an integrated picture. Those things help us forecast those effects with a greater degree of confidence.
It's really important that research on stratosphere action.
That's a cutting it short decision by the looks of it. So just, I wonder if the crew could just put some chairs back on the stage for me, it'd be most kind. Crew includes me, by the way, as well. So, one more panel for your delectation. And looking forward very much to this one. So we've got Hannah Al-Ali, who is Dean of Faculty, Emirates Aviation University, and kind of the linchpin of this whole event. We have Kelly Wanser from Silver Lining, which is lovely, who's going to conclude after this panel discussion, and Thuraya Al-Ali as well. So looking forward to this debate. And what this is about is bringing it together. It's about the UAE and the local context. So, Hannah, I'm going to ask you to kick off. Do you have a mic? Here we go.
So, I already introduced myself, so I'm probably not to introduce myself again.
Do it, do it.
So, I'm Dean of the Mathematics and Data Science Department at Emirates Aviation University. So, we're here today to talk about Project Heatwave, which these other people are here with me to also talk about the issues with heat waves. The reason that I feel so passionate about this project is obviously the UAE is going to be one of the first places affected by these extreme heat waves. And these heat waves are going to be at a point where we will not be able to continue day-to-day functions. Our lives will be impacted, everyone. And we need to have some sort of system in place for when these happen, because they will happen. It's not about prevention, it's about how are we going to predict them and have a plan to basically have a solution for this so that we can continue our day-to-day lives. The UAE itself is a place which, thrives off the economy, and we constantly have construction going on. We constantly have new buildings, new things coming up. If these people can't work outside due to a heat wave that, say, is for a day or a week, we don't know how long they can last. That means we have so much backlog on how long those things take to process or work, and obviously our lives will also be affected. If it's such extreme heat waves, generators will not be able to work. Hospitals can't function. We can't function. Like, this is a very, very critical condition that we can't put ourselves in. So we need to find solutions before it gets to that point.
Kelly, do you want to explain who you are and what Silver Lining is and does?
My name is Kelly Wanser. I am the executive director of Silver Lining. We are a nonprofit organization focused on near-term climate risk. So in particular, the next 30 or 40 years, when scientists have projected that the climate system will continue to warm, even if we're very good at preventing greenhouse gas emissions. So coming into this problem, our concern was that looking at climate change in particular, a lot of investment and focus has been on preventing emissions, which is excellent. We're not where we need to be. But the place we didn't invest maybe enough in that is now so relevant is how is the Earth system responding? How much do we know about what the conditions will be? How well can we predict that? And then what do we have in our portfolio of responses to keep people safe? And what I think is powerful is that we have information tools, we have technologies, we have things like they do in the Hannah Center to apply to this problem, but we need to apply them aggressively. And in a region like represented by the UAE, where extremes are extreme, there's a real opportunity to apply what you've been very good at in innovation, in critical investments, in focus on the future, to this kind of problem in a way that is critical for the UAE, but also beneficial to the global community.
Thank you so much. And last but not least.
Hi, good afternoon, everyone. My name is Thuraya Alali, and I'm a climate negotiator for the United Arab Emirates. I was also representing the UAE at COP28. I was actually at COP27, 28, and 29. So I think from my perspective, I can kind of give an overview on the multilateral system, how multilateralism is working, how the UAE has been at the forefront in trying to push forward international climate policy, both nationally and internationally, and how the UAE is really trying to be a facilitator in this space, and how the UAE is recognizing the importance of climate change, and the science is clear. I mean, we've all been listening to the conversation earlier today. We are in a critical decade. We need to be aligning ourselves to, reducing our GHG emissions to 1.5 by 2030. So I will be hopefully giving some insight on what the UAE is doing to bridge that gap.
I'm going to keep you on the spot there. The next COP, how do you see that kind of progressing in terms of UAE and impact?
Sure. So what I would say is that at COP28, that was a COP that signaled ambition. And what do I say by ambition? We had the first global stocktake, and what the global stocktake aimed to achieve was it aimed to achieve, assessing the progress of countries. What have we been doing? And where are the gaps, and what are the opportunities and challenges to bridge those gaps by 2030? So, it was a landmark decision where countries agreed that, we have to be reducing our emissions by to 1.5 by 2030, and actually agreeing that we have to transition away from fossil fuels in a just and equitable manner in a way that can be nationally determined as well. So each country will be doing their part in a way that is sustainable and equitable to them. COP29 was then, let's say, the COP of finance. Where is the money going to come from? Who is going to be paying? And who is going to be supporting the most vulnerable, in this climate crisis? There are a lot of developing countries that, do not have the resources to mitigate or even adapt to climate change. And we need to kind of work collaboratively in the spirit of international cooperation on how can we provide those resources to those who are most in need. And for example, at COP28, we did launch a loss and damage fund, which aims to address those who are particularly vulnerable with risks to climate change, for example, the flooding in Pakistan. So this is kind of like a pledge from countries to provide resources to those who have had issues and disasters in their respective countries. So this year was very important in setting up a new qualified goal for finance, where countries are pledging, specifically developed countries are pledging money to those who are in need. And then going on into COP30, I think the conversation will go more into the aspects of international cooperation, and I think we all have to be developing our nationally determined contributions as well, and that will be a very big space for parties to discuss, where they're at in that conversation.
Nothing like a small challenge, I think.
Definitely.
So just bringing that around again for perhaps Hannah, how do you see, this is one of the countries that focuses increasingly on research. We're starting to get into that, but also when the world's first minister of AI, how do you see AI and machine learning playing into that, supporting our journey to reduced heat?
So
small question, Hannah.
So I have a big answer. So basically, we can use machine learning to forecast these heat waves, and it will allow decision makers to mitigate the extreme circumstances and impacts that will happen. By doing this, we need to use things like physics-informed neural networks. These networks allow us to have sparse data, which unlike most machine learning or data-driven models, and they allow us to predict and forecast these heat waves for how long they're going to be, when they're going to happen, which areas they're going to happen in, and allow us to make informed decisions of how we can then minimize impacts to cities, countries, and other vulnerable people. So physics-informed neural networks, I'm not going to bore you too much, but basically we are looking at usually traditional models will use mathematical equations, so PDEs and Navier-Stokes, I'm sure you've heard of, about fluid flow. We can use physics, so for example, heat equations and flow equations, and put them into machine-driven models so that they can train their data, and so we can better forecast and predict these outcomes and heat waves with less time and less computational power, because usually machine learning methods will require a lot of data, and you have to train the data on events that happen naturally. The data that we're going to be looking at, we don't have that much, and also these heat waves are unprecedented. We don't have the data. They're going to happen and they're going to occur, so we need to train on new data, and they have to adapt to the new data. In order to adapt to the new data, we use these physical laws which allow us to keep the machine learning models in a state where they adhere to the physical dynamics of the weather system. Otherwise, we can get really, really good predictions and accurate predictions statistically with minimal error, but they're actually scientifically won't be true because they defy the laws of the weather, and that's where the issues occur. So that's why we want to use AI and PINs, or physical informed neural networks, to overcome this issue.
Thank you. One of the things that strikes me is the range of universities sitting around this room, the range of collaborations that we saw on the rather jittery screen earlier on. So Kelly, do you want to just talk us through that collaboration and how that should play an impact?
Thank you for asking the question, and I'll just start by saying I think physics-informed neural networks are extremely cool. So I'm very excited about that kind of work and these kind of collaborations. And one of the reasons that we showed you the video, which discusses kind of the most global, the most extreme form of intervention, if you like, is how important it is that we work on these problems together, and that we take the best minds from all over the world and the things that they do best. We heard from Pakistan that they actually have one of the most advanced frameworks for heat response currently. We have amazing advanced technology here in the UAE. So how do we bring people together to both work on these problems and accelerate innovation, and then to share the information about what to expect, about how do we keep people safe around the world, and what does this mean for our region, for our community? What does this mean in the UAE for lives, for health, for safety, for economics? And so these collaborations where you have universities from here locally in the region, including both Dubai and Abu Dhabi, and then around the world, how we're collaborating together to accelerate what we know, and then ensure that we're making decisions together, especially about the biggest and most globally impacting things.
Thank you. Perhaps in terms of a last set of comments from everyone, how do you see the UAE's response to where we are now? And
Sure. So I think the UAE has responded in terms of creating, and updating its policies here in the UAE. For example, at the end of 2024, the UAE introduced an updated climate law, which aims to, reduce carbon emissions. It's introduced a set of carbon trading systems, and also we have submitted our updated NDC 3.0, and this is basically an initiative from the UAE to start encouraging countries to do so. We're also part of what we call the Troika, which was basically the UAE presidency, the Azerbaijan presidency, and the Brazilian presidency for COP30, where we are basically trying to encourage countries to submit their NDCs that are 1.5 aligned with the outcomes of the global stocktake. And what we are trying to do is we're trying to increase the spirit of international cooperation, because this is crucial in the multilateral space. It's crucial for countries to come together and, you know, to really fight together for this global concern. And what we have also been trying to promote is working with the UN. They have also set up the UN the NDC partnerships, which gives guidance to countries on how to implement their NDCs, provide perhaps issues in terms of funding, you know, things that maybe some countries don't have, you know, the resources to do so. And for example, NDC 3.0 in the UAE is a 1.5 aligned NDC. We are aiming to reduce our global house gas emissions by 31% by 2030. But we're also trying to aim to do it in a way that is just in terms of improving our economy as well. You know, we want to make sure that the UAE is striding in its economy, as well as, you know, mitigating the effects of global warming. And in that sense, you know, we are aiming to increase investments in renewable energies, electric vehicles, and so on. So that is basically the conversation that we have started, and, you know, we're trying to be a key player and a promoter in this space.
So it's an aggressive approach, but pragmatic in its application is what you're describing. I'm going to throw a curveball at Hannah. And the curveball is, if you're looking forward in terms of your research and Emirates Aviation's research in the next 5 years, how would you see that fitting in with this journey?
So this is where AI comes in. We need a lot more money. We need to basically build these networks, these models. They obviously run simulations, have surrogate models to train all these models to be able to predict and forecast all these conditions. And to go that way, as I said, we need a lot of machine power, as well as the fact that we have these physics-informed neural networks. We still need machine power. We need models, numerical models to simulate and train these models. And that's why we have to focus on these areas. And if we're able to do this, these will allow us to decide what's best to help the situation that's going on. What cooling things do we need to create? What techniques should we use to stop the impacts that are going to happen to us? Because they will happen, as I said. And it's about what's the best way, how can we optimize what we need to do? Where should we put our resources? Where should we put our money? And that's what the whole point of this is.
Fantastic, thank you. I made a bit of a mistake the last time and I didn't throw the floor open for questions, so that's entirely my fault. This time I'm not going to make the same mistake, so I'm going to ask anyone to raise their hand who'd like to ask any questions before I ask Kelly to conclude for us. We have a regular contributor. Thank you, sir.
So the problem is that if tomorrow we achieve net zero, we still will have climate change impact for a while, for quite a while. So yeah, we are doing a lot of things. We are all contributing. But I think it's more like a comment than a question. But we still have to put lots of efforts onto things, adaptation and climate interventions. And that is written over here, but I think we did not talk a lot about that. Now, climate interventions can be done, or probably we are proposing also at a mesoscale. I know how to interpret it in plain English, but it has to be done at a micro scale. Hello? Yeah. And at urban scale. For example, the way we are building our buildings, the way we are making our roads, all the infrastructure, is it compatible? Is it climate friendly? I'll give you one example. NEOM project in Saudi. 200 meter wide, 170 kilometer long, probably 1 kilometer tall line project. Beautiful. It's a engineering masterpiece. But what you're actually doing, you're actually dividing the area into two regions, two climatic regions, number one. Number two, you have made pigeonholes for humans. Now they have reduced it to 1 kilometer. Okay? But ideally it is a good solution in many respects. The example I gave is that the reason is that it is easy to spend money. It is easy to give bring lots of engineering into fancy projects. But do we really spend time and efforts to make our infrastructure compatible with the current climate change impacts, or to reduce the climate change impacts onto humans?
We'll chuck it one way. I'm going to put another hat on as an urbanist, and I think there are huge challenges of how humans interface with the environment right across the world, and that's one of the biggest debates. And I think one of the things in terms of where Dubai is pushing its research is into how cognitive cities and how we live in our environment. So that's particularly important, and that's where places like we can research. Kelly, do you want to pick up on that as a sort of do you want to respond?
Well, I kind of wanted to say that it sort of points out this problem of that extends from the level of the person to the level of the community to the level of the infrastructure to the level of the atmosphere itself, which is, if you take heat waves, how they affect people, communities, infrastructure, and then, whether there's anything we need to do at the larger regional or global level. Your question is the question that applies across the board, which is, do we have the analytical tools to help people say, like, this is the right thing to do? We're making the right policy decisions for workers. We're building the right building infrastructure. We're researching and thinking about whether we need to take more drastic action. And so the problem is that we don't have the tools that are up to the task right now, and not all of these projects are getting the right level of analysis. I don't know about NEOM, it's a pretty cool project, but that the investment in that ability, the level of uncertainty we have right now, and the gap that we have in being able to do that problem, that's unacceptable. And it's easy to solve. We need to just make those investments to apply, the talents of people like Hannah to those problems quickly. So I don't think it's where it needs to be, but I think we can improve it quickly if we make the investments.
But that's also where the nexus of research is and policy. Can I just take maybe one last question from just slightly short of time. Sorry, front row. Thank you.
Hi, thank you so much for the whole presentation you guys did. That was amazing. One question that I have, which is, we know that UAE is the top when it comes down to putting action behind research. And coming from a Canadian background and living in North America and having been in AI and as well as construction and multi-level businesses that I've been through all my life, I've realized that in AI, my biggest pushback is researchers. So every time I sit down in a room with researchers, they really hate the idea of AI, to be involved in that, which is kind of crazy because we are headed toward that. So that's one point that I need I wanted to ask that for the panel before and then for you as well, to see what are you guys doing, the people that are not in UAE, because UAE is really going heavy with that. What are you guys doing in your own research? Are you guys implementing anything AI level? And the other thing is it's more of a comment from a person who has a lot of social media presence, who have used social media to kind of like push the ideology of making things mainstream. I feel like one of the biggest problems is what we're talking about right now, but it's not mainstream. So the biggest problem is when you go to a person who is young, let's say under 30, and you bring this conversation up, they're not going to have any background to it. they're just going to dismiss it as just something else because it's not explained in a way where a normal human being, not a room full of doctors and researchers, they kind of understand this. So me watching the previous video, I have background in AI, I have background in research, I understand it. But if I come to anybody on the street and show them the video, they're just going to turn that off because it's too big words to them, they're not really gonna get it, and they're gonna say, oh, this is fake, they've been talking about this for the last years. How can you guys utilize the social media presence in the world, which is the biggest right now, to make this subject very mainstream, that you can have the push of the majority of people to be able to push the right people to make the investments around the world to resolve the issues that you guys are talking about?
Thank you. Who are you, by the way? Do you want to introduce yourself?
I would rather not.
Okay, that's your decision. Kelly, would you like to respond?
I'm happy to take a start. There are a couple of very large questions embedded in that. And so to the second part of your question, how do we make this easier to understand, especially for young people? My organization actually has a global young leaders initiative, and due to visa issues, we weren't actually able to have one or two of them here. But they best explain it to each other. And there are certainly amongst young people at least an overarching sense that the future looks dark and that the climate system is going into a bad place and the adults in the room have not solved it. So I do think that overarching message is there. How we then get across, what the various considerations are and options are. And so we've worked with very smart young people to try to get those messages across, I think. And to your question about AI and advanced analysis techniques, one of the challenges of the climate problem that I've learned from Jean-Francois and others is there are parts of the problem that AI really lends itself to and parts of the problem that it doesn't, mostly having to do with whether or not you have data to train the AI. And parts of the Earth system operate over very long periods. Parts of the Earth system we don't have enough data on. And so you've got to really combine what scientists know theoretically with what AI can do. But I think that's where, the science-enabled work that Hannah's team is doing, for example, that's why it's exciting. So, it's getting researchers okay with where AI can fit, and then AI people understanding that science-informed AI is really needed in order for these things to come together.
Well, thank you. Just if you could put your hands together for a fantastic panel. Thank you for their efforts, and thank you for participating so much. Wonderful. We'll exit the stage left and leave it to Kelly to just wrap things up. Thank you again.
Well, thank you very much, David. And I want to thank all of the panel and the hosts here. It's really been exciting to work with the collaborators in the UAE, as well as collaborators from different countries on Project Heatwave. I think what's emerged is that there's a universal nature of the problem, and it becomes clearer when you look at the problem of mortality, of real death and suffering, and the very clear problem of surface heat. And do we have the tools to do that problem, and do we have the collaboration to do that problem together? And so I'm very excited at the prospects of this project and the support of all the partners and the support of the different governmental organizations and intergovernmental organizations involved, and seeing you all here. And I hope that everyone will continue on this journey, because I think there's a way that we can really make a contribution to the successful outcomes for people here in the UAE as well as globally. Thank you.
Thank you all again. Much appreciated. Hannah, last word to you.
Thank you, everyone, for coming. I don't think my mic's working, but thank you, everyone, for coming. I appreciate you all spending time here. Thank you for being interested in this, because obviously it's something that's going to impact all of us, so it's so important. And please help yourself to food and drinks outside.
Can I have a photo, please?